Hello, today we're going to have a quick overview of our custom cross-section properties calculator. So first thing first, when I open this, I can come here and look at the design assumptions that we're using. These are always useful to take a look at, especially the first time. I'm going to close the details mode. And so now the first thing we want to do when we're looking at the custom cross-sections is generally we're going to want to look at this analysis type. And actually, we're going to want to change it to none. And the reason we do this is because the analysis behind the scenes is actually quite computer intensive. And so we set this to none. It doesn't run the analysis behind the scenes. Everything runs smoothly. And then when we're ready to actually run the analysis, we can come back and change this setting. So going to the left now, I've got my diagram of my cross section. You can see right now I've got a fully custom cross section. So you see for an I section, I've got my depth, my width or breadth, my flange thicknesses, and my fillet radius. I can also say rotate this section. So I wanted to say I have it at 45 degrees for some reason, no problem, I can do that. Similarly with mirroring, although for a section that's doubly symmetric, that doesn't really do much. If you look, we've got quite a few different types of sections, whether that's just a rectangular flat bar, we've got our hollow sections, we've got monosymmetric I sections, for instance, if I've got, say, a built-up beam or something like that. We've got T's, angles, we've got cold form steel, Cees, or bent plate, whichever one you want. And then we've also got these closed sections that are arbitrary. So here you can enter basically the lines that define the edges of your cross section. So that's something that you might find useful as well. Next, we've also got our steel database. So if you're in the US, this will pull from the AISC database. So right now we've got a W12 by 45. I could come here and perhaps select a angle. And if I select this, you'll see I've got my angle and we'll be able to calculate all the section properties for this angle. We can also look at, say, if I've got a pile, I can remove this and say pick a HP 18, so 18 inches by 18 inches. And you'll see I'm choosing a pile here for a very specific reason, and that is our corrosion and perimeter offset. So right now it's set this to none. What I'm going to do now is I'm going to run just the elastic analysis. So we're going to let this run. And so you can see here, for instance, my section modulus is 335 cubic inches. And so looking at this now, if I come here, I've got my different options. I'm going to select manual offset. And right now it's set to minus 0.05. Maybe I'm putting this pile in a very corrosive soil, so I want to have a big corrosion offset. I'm going to put a 1/4 inch. And so going back, you can see now it's a lot thinner of a section. And if I look at my section modulus, it's now 179 cubic inches. So it's reduced a significant amount. So this is super useful if you are designing piles and you want to be able to check with a corrosion offset. Perhaps it's mandated by code or your contract requirements. It's very useful for that. If I go back now and set this to none, that 179 there, you'll see becomes 335, just as we'd expect it to change. We've also got our material properties here. Now, for the moment in North America, this doesn't actually do much. We are currently working on building functionality to let you link these custom cross sections with our design calculators. And so once that's implemented, we'll then be able to set material properties directly in this cross section properties calculator. Now, one other thing that I'd like to show you is our ability to create composite sections. And so what I'm going to do for this, actually, it's quite useful. I'm going to create a new calculation, scroll down to the custom cross sections, and you'll see we've got a few kind of presets for you already. We've got channel and angle, different types. In this case, I'm going to select an I section and plate. And so, again, I'm going to set this to none just so things run a little faster. Looking at this here, you can see I've got my I section here, W12 by 45, and then I've got my cover plate at the bottom. But perhaps I actually wanted my cover plate to be a little narrower than the beam, just so that there's room for the welds. So if I wanted to do that, I can see I've got my composite section geometry. What I would want to do then, I've got my width. You can see right now it's set by the formula to be equal to the beam width. I could say set it minus 2 inches. And now I've got cover plate. But now if I look at the diagram, oops, it's not aligned anymore. So I can now go to my shift section by and just move it by 1 inch. And now my cover plate's perfectly aligned. And I can now go back and perhaps I'll do a elastic and warping analysis in this case. And so I can see I've got my moments of area based on the principal axis. So use this for the inertia. And then I've got my section modulus that's calculated for me. And then I can go down and I can see I've also got my torsional constant and my warping constant, which are quite difficult to calculate typically. And I've also got my monosymmetry constant, which are useful when we're dealing with lateral torsional buckling. So that about concludes just a quick overview of the custom cross-section properties calculator. As always, if you've got any questions, you can hit the big help button here and you'll see we've got some articles here, or you can also click the ask button and send us email. We're always happy to help you as best as we can. Thank you very much.